Okay, so in this video, I'm gonna demonstrate the results of the previous recording inside the abandoned part of the work building. I'm gonna start by demonstrating the video feed running with LSD-SLAM, and then I'm gonna demonstrate the video feed using LSD-SLAM. On this screen here, this is our viz, and this is going to track the odometry of the Bebop drone. Make this a little bigger. We also have the video feed. Minimize this for now. I'll start that ROS back again so you can see the video feed. So here we see the video of the drone flying, and that's what's going to be fed into the monocular algorithm. We also see it tracking and computing its odometry as it flies. That's what these red arrows represent. So minimize that a little. We're going to go ahead and actually restart this. So first we'll start LSD-SLAM. Wait for that to load. Okay, now that LSD-SLAM's loaded, we'll go ahead and start playing that bag back. Okay, now it's trying to initialize the map. Once we see these lines turn into squares, it'll have tracking. Now it has tracking. At the same time, like before, we can see the movement of the drone being tracked by the odometry. Here, I don't know if it's a break in video or the turn, but it loses tracking completely through that turn. However, if we notice here in our viz, it hasn't lost track of the odometry. So and I believe here it landed. There it's landed. So we'll take a look at the results of our viz. This trajectory's seen to accurately reflect what happened. Went forward, turned, and then landed. However, this one, we see where it was going forward, but once it turned about here, we lost it. So that's LSD-SLAM. Now we're going to do the same thing, but we're going to do it with LSD-SLAM. So we'll launch that. We'll wait for it to load. launch RViz. We'll go ahead and play that back again. Okay, so LSD-SLAM is launched. And like before, it seems to be tracking. I'm going to show a different map here. This is the map that it's actually generating. And the blue and green line, that's its estimated trajectory. And like we saw previously, during that turn, this algorithm too has lost its ability to track. So the goal of my research will be to combine the information received from the odometry, which we can see here again in RViz. Well, let's see, we may have to restart the bag. But this odometry information here, these red arrows, the goal is to combine that with what's being computed here as far as the map to make a better estimate. So for instance, when it turned, hopefully we could then still have enough correlation to continue the map. So I hope that demonstrates my current objectives. Thank you.